probability. So 14.3, independent events. So, two events are considered independent if the outcome of the first event does not affect the outcome of the second. If two events are independent, then the probability of those two things happening, basically one after the other, them both happening, is probability of A times probability of B. So, maybe this will help you. When you're using an OR, like we learned about yesterday, it's going to be addition. When you're using an AND, it's going to be multiplication. Okay? So that kind of helps you to figure out if you're going to be multiplying or adding probability. That's like a general rule. So, let's go ahead and look at some of these examples together. Consider flipping a fair coin. On the first toss, what is the probability of heads? 50%, 1/2, or 0.5. On the second toss, what is the probability of heads? 1/2. So I see why you thought it was 1 out of 4. That'd be like first one being heads and then the second one being heads, but we're just strictly talking about the second one right now. Okay? But I see why you would say that. So if the first flip results in heads, what is the probability of heads on the second flip? So they're telling us if the first flip results in heads. Does that affect the probability of the second flip? No, so it's still 1/2. Explain if coin flips are independent. Would you say yes they are or no they're not? Yes, because they do not affect each other. So does anybody have any questions about coin flips so far? They do not affect each other. All right, perfect. Let's move on to the next example. So what is the probability of an ace being drawn on the first card when we have a deck of 52 cards? 4 out of 52. Which you could reduce to 1/13. Okay. What is the probability an ace is drawn on the second card if the first card is not put back in the deck? 3 out of 50. 51. So if we're taking a card out and not replacing it, we have less cards to pull from. And if the first one was an ace, we have less aces in the deck to pull from. So does everybody understand why both the top and the bottom were affected? Okay, so explain if getting an ace on the first and second cards are independent events. Would you say independent or dependent? Dependent.
Why did it word it like that?
What do you mean?
Like to see it explained. Never mind.
Oh. The second is affected by first. So what you're going to notice as a pattern is when something isn't replaced, like a deck of cards or like marbles, it does affect the probability of the second one because there's less to pull from, right? So does anybody have any questions about that? All right. Determine if the following events are independent or dependent. Flipping a coin and then flipping it again. Independent. Choosing a black 7 from a deck of cards, not returning it, and then choosing another black 7. Dependent. Pulling a blue M&M from a package of candy and then pulling a brown M&M from the same package.
Independent.
Who says dependent? That's good. Correct. If you have a bag of M&Ms and you are taking M&Ms out of the bag, isn't that changing the denominator of the probability? So even though the numerator wasn't affected because we haven't pulled any brown M&Ms, even if we pulled blue, isn't our chances of getting the brown increase every time we take one out that's not brown? So that's why the probability is affected. A couple's first child having red hair and then their second child having red hair. Independent. You don't run out of genes. It's not like that, yeah. All right. So suppose you roll a red number cube and a blue number cube. So when we're talking about number cubes, I'm talking about like a 1 through 6 standard die. Okay, just to be clear here. what is the probability that you will roll a 3 on the red cube and an even number on the blue cube? So we're going to break this down into two parts, okay? Rolling a 3 on the red cube, what's the odds of that happening? 1/6. When we do and, we use what operation? Good. And, because we want these two things to happen simultaneously. And when you want two things to happen simultaneously, you're reducing the chance of those two things happening, right? So you need two instead of just one thing to happen. So, an even number on a blue cube. How many of the numbers are even? 3 out of 6. So that's 3 out of 36, which is 1/12. So any questions about that? Okay. So you choose a tile at random from the game tiles shown. You replace the first tile and then choose again. What is the probability that you will choose a dotted tile, then a dragon tile? So firstly, what's the chance of choosing a dotted tile? 4 out of 15. And, so it's going to be? Multiplication. Then a dragon tile. But you replace the first, so we've reset it to be 15. You know what I'm saying? So how many dragon tiles are there? 3. So that's these guys right here. This one, and this one are the dragon ones, by the way. So that's going to be 12 out of 225. I don't know if that, I think it would reduce by 3. I guess it doesn't really matter, but it does become 4 out of 75, if you're wondering. Okay. Suppose you choose a tile at random from the tiles shown. Without replacing the first tile, you select a second tile. What is the probability that you choose a dotted tile, then a dragon tile? So what's the probability of choosing the dotted tile first? 4 out of 15. But then, to then choose a dragon tile, because there's no replacement, what's it going to be? 3 out of 14. Because there's less to choose from, right? So your odds of choosing a dragon tile have been increased because we pulled out one that's not a dragon tile, okay? So that's going to be 12 over 210, which becomes, what? Yeah, we can go even smaller than that. We can go 2 out of 35, right? So any questions about that? Now on the test or quiz, if I want your answer in decimal, for example, I'll just do one so you can see 2 divided by 35, that's going to be 0.06, okay, or 6%. I will always tell you what to round to if it comes to it, like hundredths place or all of that. So just be aware of the different forms of which probability can be presented. Okay. 1 freshman, 2 sophomores, 4 juniors, and 5 seniors received top scores in the essay contest. To choose 2 students will read their essays at a town fair. 2 names are chosen at random from the hat. What is the probability that a junior and senior are chosen? So before we do this problem, I want to talk a little bit about implied independent versus dependent. So there are going to be real life scenarios where they're not going to straight up tell you if it was replaced or not, but you have to think about it logically. If we're doing an essay contest and we're trying to pick 2 winners, are we going to ever have the same person read their essay twice? No. So these events are going to be dependent because we're not going to replace the name that we already pulled. Does that make sense to everybody? So what is the chance that we pull a junior on the first pull? 4 out of 12. And multiplication, what's the chance of then pulling a senior?
5 out of 11.
Good. So you could reduce this, I don't know. I'm just going to do it as a decimal. Yeah, you have a question? Go ahead.
Can you reduce the fraction first if you still get the right answer?
Yeah, of course.
Like if I did 1/3
Yeah,
and it'd still be the same thing.
exactly. Yeah, it'd just be you would already get the reduced form. So you can definitely do that. So a little tip, like it's not wrong to do it anyway, but you know with the addition ones, you usually want to reduce at the end because if it's like out of cards, 52, 52, you can add the numerators because they're a common denominator. With these, it doesn't matter because it's multiplication, so we don't need to have common denominators. So that just saves you a little bit of arithmetic difficulty. So it says, given a standard deck of 52 cards and a fair 6-sided die, what is the probability of picking a diamond and rolling a 4? So what's the chance of picking a diamond?
13 out of 52.
Good, 13 out of 52, which reduces to 1/4, right? And then what's the chance of rolling a 4?
1 out of 6.
So the chances are 1 out of 24. And would you say these are independent or dependent? Independent. So as you can see, your chances of picking a diamond are pretty high. Your chances of rolling a 4 are pretty high, but the chances of doing those two things at the same time is lower, right? Because you have to have both things simultaneously happen at the same time is much more rare. All right, I'm going to hand out homework. You have the rest of the period to work on it. You should be able to get it done because it is a front page only.